Hello everyone and welcome to my video course about machine learning. Just a little disclaimer, I'm not a specialist, I'm also a student, but I decided to not just watching videos and doing some labs, but also whatever I just learned, I want to share directly with you. So that's why I'm here. With no more words, let's start. And what is machine learning? If you search machine learning, this term online, and you see enormous amount of definitions, and they all reflect the truth. But I like one definition. Machine learning is a set of tools that allow a person to explain patterns from the real world using machine code. In other words, all the algorithms we study are just mathematical tools from probability theory and mathematical statistics applied to some different real world data examples. Just one simple example is predicting stock price. It's very basic example that is used during machine learning courses. Let's imagine we want to predict some stock price for a specific company. We can predict stock price, what the price will be tomorrow or maybe next year. And more than that, we can explain how the price is formed, what factors contribute to it. And these predictions are based on identifying and identified patterns happening in the real world. There's no any magic in machine learning. Some people in the beginning might think that there's a black box with neural networks within, and some magic is happening within that. But basically, machine learning is very simple mathematical tools that are used, and everything that ML machine learning models can do, people also can do with strong mathematical backgrounds. Like a person with the paper and a pen, if we can give this person a few hours, he can derive mathematical models that can produce exactly the same prediction. So if that is so, why we use machine learning at all? This arises as a natural question. If there's no any magic and we can simply use math and a skilled person, so why we do that? And to see why, we will look in some other examples. And the first example question or the problem we will look at is, again, how much will stock cost in a year? And particular example, imagine we have two companies, and we look at the first company stock price, see how it grew up over the past year, and study other companies whose stocks rose or fell. And now we are at present moment, and we have particular second company, and we want to predict what would stock price be. And we can use our prediction based on historical patterns, how similar companies like first one from which we got some insights, from which we got some historical patterns, how it behaved in the past. And by using these patterns, we can apply them to forecast second company future price. And why it can be beneficial and for who? First of all, for investors. If you had a model that predicts stock price, with very, very high accuracy. You could simply sort companies by expected growth, invest your savings in those, and get the most profit. And it's not just once you did something, maybe you paid money for somebody to do that. You can do it every day, every moment, whenever you want. And the second reason it can be beneficial for not reason it second group of people who can be beneficial from it, company leaders, directors needs to understand, for example, market conditions depending on how stock prices are expected to behave. They can make good strategic decisions that affect the entire company's future. Let's look at the little diagram, just visual example of the same thing, just what I said. We can see here first company share price. We got some historical patterns in the past, and we are in the current present moment. And we have second company, and with the help of ML machine learning models, we can predict in which direction the price of the stock for this company will go, on which side, lower or higher. Okay, that was the first example. And the second problem is banking client scoring. And now we will look at the second example, banking client scoring. Let's imagine another case that people are coming to you and asking for a loan. And just imagine you're a credit organization, you're a bank or something like that, and you want to borrow money to the people for their projects. But here there's a problem. First of all, you have limited amount of money you can borrow to others, and another problem is clients doesn't always pay back their loans. So for you, it will be very useful to know every time a batch of debt clients walked in, you could say for each one, what's the probability this person will default? So who can I trust money and who I cannot? Uh, for example, we have a stable business company, for example, factory, and it will be marked as low risk of being defaulted. Second one, like regular payments, maybe office work, some office company. So we have a medium risk here. And the third one with bad credit history, high risk of being defaulted. So like that, we can identify and score different types of our clients and decide with who we will work. All right, yes, that's already said. And the third idea of how we can use ML models in real life is anomaly detection. And let's imagine your work in a dangerous production faculty. Every day at particular time, administrator must press the button, or otherwise explosion will occur. If an administrator isn't at the station um, you would like to know at least 10 or 20 seconds before the critical moments. So ML algorithms with this within this funny example, they can process and alert you to these kind of anomalies before something catastrophic become might happen. Yes. A different kind of, for example, risky operations, crane operations, explosive materials, biohazard risks. So we might train algorithms to observe and identify particular situations and make an alert if something might occur. And the fourth and final example, uh, do clear customer groups exist? And if so, what are they? In the case when we are we can imagine we are working in marketing agency and we want to predict which customer groups are most likely to respond to our ad company. A human expert might guess based on intuition, but many models can analyze thousands of signals and give data driven answer. Uh, for example, we are selling product, maybe apples or some different kind of fruits, and we know that there are people who respond to our ad campaign, but others won't. So before paying money for these ads, it would be good to classify our clients, our customers to different groups. Mhm. So that is basically how we can optimize our budget and spend money for showing ads only for those people who will likely to respond to our ads. So for now, we discussed what questions machine learning algorithms can answer, and what problems they can solve. But going back to the question, what does machine learning code have to do with all this? All these models are pure mathematics, probability theory, things a great math graduate can do. So why transfer all of this logic and algorithm building into machine learning code? Let's discuss that. First of all, human is limited with the time. They require some time to solve particular problem, and in those cases where high response speed is crucial, we we have to find different tool. For example, as mentioned before, anomaly detection in an at an enterprise where something can explode if button not pressed. So machine learning models react much faster than a human. And imagine the director in this office, and machine learning model can instantly notify them if administrator might went out and is drinking coffee and not at their workstation. So if seconds matters, we want to know in advance what's going on. Second very important limitation of human expertise is experts can be very few. Mm, so we can train our models to learn highly specialized challenges, to solve highly specialized challenges that only few limited number of experts can handle. For example, very futuristic question about governing a country. There are some stories already about AI being our presidents in the future. So why not? There are maybe only 50 or to 100 truly effective presidents in the world, but we can build a robust country governance model, and it could be scaled and transferred from one computer to another. So all countries might be ruled and governed very effectively with these models. So, like this, we can solve the problem of limited expertise in very highly specialized challenges. The next limitation of human is working with big data, and it's a very big advantage of machine learning models that they can handle massive volumes of data, and the human brain has limited memory capacity. So that's basically it. The summary of this lesson: machine learning is not a magic. It solves a wide range of diverse tasks, makes human work faster and more efficient, automating complex computations and that would take humans much longer, handle complex data heavy questions. Unlike humans, ML models can process terabytes of data without memory limits. All right, that was it. Thank you for this introductory video, and we'll see you in the next lesson.